The goal of today's lesson is to figure out a shortcut for creating these polynomials or these infinite series that represent particular functions. So in class we did the long way of doing for e to the x. So there are two types of polynomials that you can create. So please make sure that you make a note card on this box. Okay? This is the general form of the polynomials. A Maclaurin polynomial is when it is centered at 0. So if I say I want a series that is centered at 0, a polynomial, it's called a Maclaurin. A Taylor polynomial is just a general form of a Maclaurin, but it can be centered anywhere. So I can be tangent to x equals 4. I don't have to be tangent at x equals 0. So a Maclaurin is just a special case of a Taylor. And the general form is this. So the first value in the function will be just the value of the function itself, f of c. The second term is the first derivative times x minus c plus the second derivative at that value divided by 2 factorial x minus c squared. Notice the derivative matches up with the factorial on the bottom, which matches up with the power here. The only difference between a Maclaurin and the Taylor is the Taylor will always have x minus c, but for a Maclaurin, that c is 0, so we just write it as x. Okay, so let's go through an example. So let's say I want to come up with a series or a polynomial for natural log of x. I'm going to center it at c equals 1. And notice I ask you for a first degree, a second degree, a third degree, and a fourth degree. So you will need to come up with the first 4 derivatives. So I'm going to start with the function, which is natural log of x. And I'm going to create my first 4 derivatives. So the first derivative is 1 over x. Second derivative is negative 1 over x squared. Next is 2 over x to the third, negative 6 over x to the fourth. Now I want to evaluate all of these where you are centered at. So if I plug in x equals 1 or c equals 1, this is going to be 0 because the natural log of 1 is 0. This is going to be 1, negative 1, 2, negative 6. Once you have this, you can write any of the degrees of the polynomials that I asked for. So the first degree polynomial, the first term is always f of 1, which is going to be 0 in this case, plus the first derivative, which is 1, times x minus c to the first power. And really it's over 1 factorial, but if I simplify this, this is really the same as x minus 1. Your second degree polynomial is, again, start with the first value, which is f of 1, plus 1 times x minus 1. You're just adding an extra term. So I need the second derivative, which is negative 1 times x minus 1 squared over 2 factorial. And again, this can be simplified to this. You do not have to write that first term, which is a 0. So really, this is the same as this. Okay, third degree, same thing. Start with the first term, which is 0, plus x minus 1 x minus 1 squared over 2 factorial. I just need to add the term that has the third derivative in it. So my third derivative I calculated was 2. So it's going to be plus 2. It's my third derivative, so third power over 3 factorial. And lastly, fourth degree, I just needed to add another extra term. So everything stays the same. But now I also need to add the fourth derivative term. So the fourth derivative I noticed was negative 6. So minus 6, fourth power, 4th factorial. So this is the fourth degree polynomial, Taylor polynomial centered at 1 that is a good approximation to natural log of x. And if you compare it on the graphing calculator, you will notice that it does match up pretty well. Now the other things that you will have to do is, if you look at this series or this polynomial, there is a pattern here. I want to actually write it in sigma notation. So natural log of x is, I'm going to write the first couple terms just so I can see the pattern here. And what I did was I reduced it. Sometimes if you don't see the pattern, if you reduce the numbers, it'll be easier to see the pattern to write your sigma. So 2 over 3 factorial, that's 2 over 6, which reduces to 1/2 here, to the 1/3 here. Okay? So notice if I just write the first three terms, you can see the pattern on the bottom. This goes on infinitely. So I can rewrite this as a sigma as n goes from 1 to infinity. It is alternating, so I need this. It's x minus 1 to the nth. That is the sigma that represents this entire infinite series. Now you can change this n equals 1 to be n equals 0 or anything that you want, but then obviously these will have to change accordingly. Okay, here's the last piece. Now based on this series that you came up with, tell me for what values of x does this series converge to natural log of x. So I will need to use the ratio test here. Okay, it is not a geometric, so the ratio test is the only option that I have. I'm going to set up my ratio test. Okay, there's my setup of my ratio test. From here, I'm going to simplify a couple things. Notice the negative 1 will drop out because it's the absolute value. I'm going to do one step of simplifying. The x minus 1 to the n's will drop out, so I'll be left with the x minus 1 to the first and an n plus 1 on the bottom. But the limit of n over n plus 1 is 1, so this limit is really x minus 1. And the ratio test says that this only converges if this is less than 1. If you solve this inequality, you should get from 0 to 2.